on one hand, there's a level of depth in the type of analysis that we're able to do and the type of linkages that you're establishing between the physical environment, the economic environment, and the social environment with a lot more ease that we could compare to previous modeling efforts. And I think the level of depth, the knowledge that we're building to understand our cities and our regions is a lot more sophisticated. But on the other hand, the ability to translate this knowledge in a language that our elected officials, our planners that are not necessarily quite versed with the technical tools that you all have, is pretty amazing, and I think it's already creating an impact. And I think they're part of this exciting moment, and I'm very thankful to Paul for taking the lead on that, but to all of you for kind of applying yourself to provide this new domain of knowledge, and not just knowledge, but again, engagement with our local planners, with our regional planners, with our elected officials, with our community organizations, to understand how our cities are growing and maturing over the next decades. So thanks, Paul.
Thank you very much, Mary. All right, I've been instructed to stand up here because we have microphones, one very large microphone standing in my face. I'm Paul Waddell, and I am a professor at UC Berkeley, and
if we're going to use it,
there we go. If we're going to use it, we really have to do it right. Okay, there we go. If I get too loud, tell me. And I'm founder and president of Synthicity. I've known many of you for a long time, so I don't have to do too many introductions, but we've been doing UrbanSim user meetings for quite a few years. I think the first one was in, what, San Antonio? Is that right? And we had a pretty good turnout then. What year was that? Anybody remember? 2005? Yeah. So we've been doing it for a while. And we were pretty good about doing it on an annual basis. I think we missed a year somewhere when we were incredibly busy with one of our various re-implementations of the platform along the way. And you know, people have changed locations and various things have happened along the way. But you know, it's been a fascinating journey so far, and I think it's getting more interesting by the day. So last year we had a meeting here. It was in summertime, and I think we had really terrific turnout because people found ways to couple vacations with a conference. And right now we're at school season, and I think it's a little harder to do that. But I'm delighted that all of you could come. And since last year, Synthicity as a team has grown by approximately 100%. A lot of people that you didn't meet last year are now with Synthicity, and the team has really grown quite amazingly. And you'll get a chance to hear from most everybody over the course of today and tomorrow. So what I'd like to do is kind of break the ice here a little bit with introductions. And I think it's pretty amazing we've got such a great assembly of people from all over the place. You just heard from Miriam Chuan. You didn't actually introduce yourself. And the title is Planning Director.
Planning and Research Director at ABAC.
Planning and Research Director at ABAC. So why don't we go around this way? Jason?
Sure. Jason Oliveira with Synthicity, Product Manager and User Experience Architect.
All right. I think we'll have other people coming and going over the course of the next 2 days, so hopefully we'll get a chance to meet them. And you came in, so. Great. So welcome again, everybody. In terms of logistics, I think there's coffee over here, restroom outside, cafeteria just outside, and a great coffee shop. I can't remember the name of it, just a half a block up. What is it? Kefa?
Kefa.
Kefa. Okay. And then Peerless, Mike, you were saying up that away. So at the appropriate breaks, ask the experts where all the good stuff is. All right, so again, welcome, and I think this is going to be a really information-filled and intense day, as will be tomorrow. So we're ready to roll up our sleeves. I think with that, I'm going to go ahead and roll into the morning session, which is a series of presentations that are sort of organized ahead of time, and then more of an informal discussion with users of UrbanSim that are either just getting started or have been working with it for some time that are not listed here, and some brainstorming about priorities and feedback and new directions. So with that, let me turn it over to Mike Reilly, who will talk about some of the experiences here at MTC. And do you know where that? Oh, you don't have to have a presentation.
Oh, sorry. I thought you did. Thanks, Paul. So again, welcome to Oakland. I think I've met many of you, almost all of you. And I've talked in the past a bit about what we've been doing here at MTC and ABAG in the last 5 years or so, 4 to 5 years, on our last regional transportation plan, sustainable community strategy, and the EIR work related to that, which was our first implementation, Bay Area UrbanSim 1, if you will, using what I call, I guess, the second version of the code, the Opus version. I don't know if that's correct, but second version of UrbanSim. And I've shown a fair number of results, maps from that work. And today, I don't want to show those again. I think most of you have seen that. And we're in the process of developing Bay Area UrbanSim 2 using the new third version of the UrbanSim code. And so I wanted to talk a little bit about, how that's been going, what I like about it. Some of the things, I've found it to be better at. It makes me think about how to approach this in a better way. A bunch of things that we could have done with UrbanSim, the old code, but I think this new code is helping us think better about how to approach some of these problems. And I don't have any maps, and so I figured if there's no maps or pictures, a PowerPoint's kind of annoying. So I'm just going to talk off my notes here. But mostly I wanted to talk about a little bit about the software design, the new way the new code works, generic, and a little bit about visualization. And again, none of the technical details, which are going to come later this afternoon, unless you have any questions on that, which I'm open to. But as for the design, so maybe not all of you heard about how it's been redesigned, but it's still in Python, using a lot of standard Python libraries to do statistics, math. The biggest change probably has been the move to Pandas, which is a system that implements, or a library that implements, at its simplest, it just brings in the ability to do tables in Python very easily. So it brings in a lot of typical database tools, which doesn't sound like a lot, but it allows you to approach tabular data, typical statistical modeling questions in a much more understandable manner. It's made Python with this Pandas package and a bunch of the underlying typical numerical packages into something that you can do. For a lot of people, I guess it's replaced MATLAB, which is something that a lot of physical scientists use to look at quantitative problems. Brought in a lot of these typical tools, and I think that's been very interesting already for me, because it's become, this package of Pandas and the other numerical Python libraries has become kind of the standard over the last 5 years. It's very popular for both, as I mentioned, the physical sciences, but even a little more accessible to me has been financial modeling, for instance. On Wall Street, this is kind of the way people are approaching these problems. And so for me, what that means is that there's a bunch of books that talk about how to use Pandas in this manner, and it's very close to the types of questions and problems we approach with UrbanSim. We look at the stock market. Believe it or not, what we're doing with UrbanSim is not so different. It's easy to use these books. There's online courses, and most important, we're in the process of trying to hire more people, and I think that we're actually finding people that have Pandas on their resume, and that's pretty exciting. They actually have used the tools. So it's become kind of a nice language that allows us to implement quicker, think about things, find more examples, and I think those are all big positives to me. And related, I think that there's been a major cleaning of the code. Things have gotten a lot simpler, still in process, I guess, but it's been broken down. To me, compared to the Opus version 2, the new code is, I know where things are. They make a lot of sense. The files that I can find things in there's fewer. They're not as deep. I can quickly find the functions I'm interested in. And I guess that's I guess what that's allowed me to do, maybe I need PowerPoints. I rely on them as notes. It's allowed me to quickly add on things because I could quickly jump into this new code package and add on quick tools for data input and output, which I found a little harder in the old approach, or less flexible in the old approach. Very flexible and quick now. And it's also allowed me this overall system, which I think some of you again have seen, is just each year is a loop of models, and each simulation is a loop of years, which is explained very effectively, I think, on the website. That's allowed me to think about some bigger questions, how we might run thousands of simulations at one time to test assumptions, to understand how our imputation of data, our cleaning, might affect our final results. So we were not doing any of that yet, but this overall clean, simple approach allows you to look at some of these people doing, again, stochastic simulations with the stock market and be like, we could pull this whole package into that same approach and start to look at some of these questions. I think it's very easy to see how to do that. Any questions so far? I think a lot of you, this is kind of standard. It's second one is modular and generic, more specifically in terms of design. All the locations make a lot of sense. The functions have been pulled out and they're very generic. I know where to look at them. The assumptions, which covers quite a bit of territory, but the inputs to the model are mostly all in one text file. This could be as simple as how many square feet per job, what are the job categories, the segmentations of the models. This is all in one quick place in a consistent format. And again, I'm saying it was terrible before, but it's much cleaner now. It's very easy to approach. And so that got me thinking, I think, both looking at the finance type examples and the way the code is. And I wanted to bring up, one of the things we're just now implementing is what I'm calling for now an accounts framework, because I haven't found a better term. I don't know if anything better yet. But in the last implementation of UrbanSim, one of the things I think I mentioned recently is we were able to represent quite a few policies very effectively. There's a lot of different existing planning tools in effect in the Bay Area, and the ability to think of new tools in the Bay Area is probably this isn't totally being pro Bay Area, but our planners are incredibly able at coming up with new ways to do planning and change levers. We have many, many things that are in force or people want us to test. And so it's kind of a challenge. People are like, well, we have rent control, but we want to do rent control with this variant. We want to do this other approach. So during the EIR work we did in the last round, we kept adding on different little policy levers, little implementations, one-off, kind of complicated, kind of hard to remember where they were in the code or to change them quickly. And so this again, this modularity and the approach, looking at examples in other places, so the idea that we could, that a lot of our policies are just in a few different areas. Zoning, variance, how much stuff of what type can be in a place. That's a lot of our policies. Then the second major package, the accounts framework, deals with designating particular areas in the region as kind of a ascending zone and taxing particular buildings in those places and sending that money to other buildings or potential future buildings in other zones. This is, again, very generic, but better example is we want to look at tax increment financing, for instance, which is historically what redevelopment uses. California doesn't do that right now, but there's been a lot of proposals to implement new versions of tax increment financing, which at its most basic is putting a tax. You look at the city of Oakland, and we could pass a law saying that any increases in value of commercial buildings in Oakland get taxed at 1% and create a fund, an amount of money that each year would come off of those increases in value, which you can think are already in UrbanSim, and put that into a bundle of money that could be then used to subsidize low-income housing in particular transit priority areas, smaller areas. And this is a version of a law that's been proposed in Sacramento a number of times. But the generic part is that we're tagging particular types of buildings, perhaps new commercial buildings, and establishing a type of tax, pulling the money off and putting it in a bank account, and then that's available in the model run to spend on subsidizing other units, low-income units, in particular zones. And that's very much like a policy we'd like to try. There's a few simple things that need to be set as to what are the zones, the types of units, what are the jurisdictional levels. But once we set that up once, but the other, we can quickly see that thinking more generically about it, and especially as we have the ability to flexibly set up our assumptions in one file and then have generic functions in another part of the code, we can use the same tools, more or less, to do something like a regional fee, where we want to put anything in our greenfield areas. Last time we wanted to do a fee on new development way out there that had high vehicle miles traveled. That we could collect money off of new development, put it in a regional account that builds up yearly that is available for a regional level subsidy, which is another policy we want to try to implement. And it's pretty much the same thing. It's just different definitions of the jurisdiction. Is it city by city or is it the whole region? What buildings are going to be taxed? What buildings are going to be subsidized? And so I found, this, again, we couldn't do this with the old approach, but this is the new clean approach, and the ability to get examples from other places led to, I think, some of this more generic thinking about how we could do this. And the list gets longer. Inclusionary zoning, like you could think each time a building, I don't know if everyone knows what that is. Inclusionary zoning is perhaps in San Francisco, someone wants to build a market rate condo building. The law requires that a certain amount of money or number of units that are low income be built either on site or close by. And that could be implemented with this same type of tool. So we're in the process of building this kind of generic tool, and I think that's the kind of thinking that we can build more of a toolbox of approaches to policies instead of during the process going, oh, I want this now, I want this other policy, but thinking about how they actually fit into these generic tools. Any questions on that? It's just supposed to be a taste of where this is headed. So finally, the third area is visualization. That's more tomorrow. We're working closely with ABAG and other jurisdictions in implementing UrbanCanvas, which again tomorrow's topic, and but also Synthicity has been working on a number of rapid web mapping tools where the results that come out of UrbanSim are quickly available either in UrbanCanvas or in a map that can either be I can't remember from teaching, chloropleth? It's got to be a better way. A map from light to dark of housing values. It can also be a map of what developed put over tiles from a satellite data or aerial photos. So we can actually do reality checks, or we did this last time, but now we're tempted to quickly look at our results because they fit in very fast. And we can say, does this make sense? Does this building make sense? These new buildings we're predicting over the next 30 years, we can quickly compare them to other data. So again, not a question of a qualitative difference so much, because we did this last time, but it took a lot of moving to other software, moving back and forth, and comparing the results, which made it less appealing if it's when you're in a hurry. So these web tools, UrbanCanvas more specifically, we're starting a project working with our jurisdictions, of which in the Bay Area there's 109 different cities and counties that all have different zoning, different building permit data, etc. Anything that's collected, it's very decentralized. So the idea here is to work with UrbanCanvas online and build a regional database, which I think, again, you're going to hear more about. This allows us to definitely offer to different jurisdictions that they can do data review. They might not trust our data. They probably shouldn't totally trust our data. We're doing our best, but they can actually look at what we have, comment on it, find errors. They can increasingly change data as they find errors, or they change their zoning code. They can update online, which saves us a lot of time. And finally, they can also look at more to the simulation results. When we come up with ideas of what we think is going to happen over the next 10, 20, 30 years, increasingly they can look at those, do quality control, that's ridiculous, give us their thoughts on does this make sense or not. And again, not totally different. We had some of these tools, but again, I think it's getting a lot easier and quicker, and jurisdictions are getting involved, which would be very exciting for us. And so, yeah, again, that's all I want to talk about for now, unless there's questions. But it's not so qualitatively different, but just a bunch of new tools, cleaner code, better ways to think about things. And I think this was a little leery maybe a year ago. Thought about maybe I should just stick with the old code. But I think there's been a bunch of good that has come out of the switch.
Thank you. We're prompts you guys in your RTP timeline right now?
Someone else want to? So we are far behind. Well, 2017 is officially the next adoption, but we're going to start. Right now we're in kind of preparing, getting the model running again, getting the right relationships created, talking to people, and then next summer we're actually going to start looking at things again more seriously. So the work is going to start summer 2015. We think we want to be using models to look at alternatives, et cetera, in early 2016.
So you're thinking of using this for the arena allocation and the EIR alternative?
So arena allocation is on an 8-year cycle. And so I think in general, I don't know too much about our plan for this, but it's.
You might want to spell out what RENA is.
Oh, sorry. RENA is a Regional Housing Needs Allocation, and so that's a state mandate to zone, for cities to zone in a way that could allow the development of low-income housing. So it's a state process with requirements and a long, detailed process. That occurs every 8 years. Tell me when I'm wrong on any of this, but then there's the Regional Transportation Plan, which we do every 4 years. And as of the last round, we also have the Sustainable Community Strategy, which in California ties into the land use, demographics, community element of the Regional Transportation Plan. So the RTP and the SES are every 4 years, but RENA only ties in, which it must tie in, every 8 years, so every other period. So this time we're looking at a smaller, simpler approach, hopefully. So we're going to use this new tool, and we're hoping it's clean. It's not as stressful as the first time. That's the hope.
I think, the improvements in the tool will be a huge contribution, but we're hoping that on the political front we'll be able to simplify the process, because last time was really high levels of insanity. We had around first 5 scenarios, then we went into 4 different scenarios, and then for the EIR we created 3 different scenarios that Mike and Paul had to go through. This time we're hoping that by the end of 2015 we get the regional control totals. By summer of 2016 we should have an idea of the 3 scenarios that we're going to run with for the entire process. So we'll see how that goes.
Question?
Right. The regional database that you're planning to build, the UrbanCanvas, would that replace local databases, or would it just addition to what we have?
I think Paul's going to have more to say about that. I think in the short to medium term, I don't think it's going to replace any local databases. But it's a chance for people to comment, first of all, on what we've collected to make sure it's right. It's a chance to provide dates for changes, but I think there is a tension. People want to control their data. They're not sure how long this is going to happen. But I think that might be one of the things to try to offer. If it's something difficult for small cities to collect, if we want them to participate, we'd like to offer them something. So I think the idea that it could replace their effort to track data that's hard or annoying for them to track might be a selling point for the regional database. So I think in the short term, many jurisdictions are leery about that kind of giving up control, and what if we don't do it 4 years out? Like they have to make sure it's kind of consistent. So building up that consistency, trying it out. But I think that is something that we want those things I mentioned. We don't necessarily want over what they're doing, but that might help them and make us all happy if that does happen, I think is the.
Yeah, just to chime in on this, I can't imagine a scenario in which we would try to replace the local data process, but right now there's not any sort of collection or sharing of that data systematically. And what we're trying to do is make it easier to not have to have such a heavy lift. Every time there's a project that requires coordination, whether it's something like the RTP or the Sustainable Community Strategies on the regional scale, or alternatively, just projects that are local but cross-jurisdictional boundaries. Like in this region, there's an El Camino Real corridor on the peninsula that has 19 cities and 2 counties involved in it. And to do that planning, to coordinate land use and transportation, they don't really have any infrastructure to share data. there's another example where there's really good motivation to just pool a copy of the data, not the authoritative original, but a copy of it, and have it in a shareable fashion for planning purposes. That's the general strategy.
Good questions. Anything else? We'll talk later this afternoon. Lunch.
All right. So next up we have Schwan and Semcog. And I'm not doing long introductions. I'll let people introduce themselves a little bit. But. Okay. It should be in that green screen right there.
Yep.
Oh, yeah. Okay.
Not really familiar with the Mac. So, oh, there.
There. Right, and then just the down arrow should
Down here. Okay. Thanks, Paul. Good morning. So what I'm going to do this morning is to tell you a bit more about UrbanSim implementation and Semcog, and then give you one application example of using the new UrbanSim to do accessibility analysis for the Detroit region. For those friends who were in SENDAC in July, the first part is pretty similar. The second part is new. And with me today, we have a couple of core staff on the forecast team. Jeff. Jeff coordinates our planning work, forecast work, particularly on the data set. Jeff has done a number of forecasts for Semcog, going all the way back to drum impel error, he just told me, and did some other interesting things and came back with the forecast team again now. We have Srisha with us today, and Srisha does both modeling and data development, and she is our chief demographer. A number of you know Guang Yu. He's not here today. He's watching us from home today. Guang Yu is our chief modeler. We have Brian. Brian does the economic analysis and employment data for us. And we have Janet, who deals with the development data, like building permits, master plans, land use data, development tracking, things in that nature. The department has 14 people right now, and most of them help the forecast work one way or the other, particularly when we are in the crunch time. So we have done 3 rounds of implementation of UrbanSim so far, back all the way to 2001, when we had a one county pilot project, and then we used UrbanSim to do our first UrbanSim-based forecast for the entire region, all the way to 2035. That was done in about 5 years, 2004, 2008. Recently, we completed another round of the forecast using UrbanSim. That was 2040 forecast, this time using parcel-based model compared to the grid cell-based model that we use for 2035. So where we are in the cycle, the forecast cycle for the next forecast, we have 3 more years to complete our next forecast, which will be 2045 forecast. We're right now developing input data for the forecast. We're just started a new household travel survey. We're going to start to collect some sample data. Most collection of the travel survey data will be done next year. We are working on building footprints. We will begin working on a new set of regional forecast totals that will be using the Reilly model. We'll have the final forecast totals completed by the end of 2016. And at the same time, we are trying to improve the UrbanSim model the 2045 demographic socioeconomic forecast need to be adopted in September 2017. We're working towards that goal. So, well, after we finished the 2040 forecast and we began to evaluate data system we have, the model system we have, and we discovered this new UrbanSim that might call it the third version of the UrbanSim or UrbanSim 2. So we did some more exploration on that, and we talked to Paul's team. We had a plan to actually convert the SEMCUP model from the old UrbanSim to this new UrbanSim 2. We did that with a great deal of help from the UrbanSim team. Eddie, Fletcher, Matt, a number of people did a great job for us to convert our model from UrbanSim old 1 to UrbanSim 2. Took about 6 months to complete that process. We first converted the basic generic UrbanSim models to the UrbanSim 2 platform, and then we converted some of the SEMCOG specific components like large area controls, employment event models to UrbanSim 2, and then finally some of the new components of the UrbanSim system like accessibility analysis, new interaction with our travel model as well. The whole process was completed about a month and a half ago, so that was pretty smooth, and we had a little bit of experience using the new UrbanSim system. A lot of this will be similar to what Mike just described. There are a lot of similarities between the old system and the new system based on our experience. The simulation theory, methods, and the flow of the simulation quite similar. The basic models are the same. Transition models, relocation models, location choice models, price models, so on and so forth. Same planning programming platform, Python-based with supporting libraries, but they're quite different actually. Data needs are similar. There's some additional needs, particularly for the developer model, that we really look forward to implementing in the near future. But the code looks quite different to us. The old UrbanSim had many pieces of code. There were more than 1,100 Python files for just the Opus core and the UrbanSim packages. So it's a bit hard to actually understand, review, maintain, and trace errors in that old system. And the code packages really relied on the lower level of Python libraries such as NumPy, SciPy, other things that Mike just mentioned. The new UrbanSim 2 system, as far as we can tell so far, really has much less code, only about 50 Python files in UrbanSim, and we have a few more in our own packages, the SEMCOG packages. We really like the new UrbanSim that uses the higher level Python libraries, pandas. Again, Mike mentioned that. And those packages are well maintained and supported by their own developers, and very powerful for analysis. And it seems to us it's much more transparent. It's much easier to understand the simplified package, the code. In terms of interface, old UrbanSim had a GUI, new one doesn't have one. Based on our limited experience, it uses the IPython notebook. It seems pretty good for interactive simulations with some limited programming background. It's pretty easy to use. I don't know the plan of the GUI, but seems the IPython notebook works pretty well so far for us. Developer model, again, Mike took some of us, and we're really looking forward to that. We haven't really done much with it yet. What we really like this new version of UrbanSim is this capability of doing accessibility analysis. We used to do a lot of local accessibility analysis and using the variables in the location choice models with the grid cell-based UrbanSim system. And once the UrbanSim moved to the parcel-based system, it lost that capability. Basically, it was impossible to calculate local accessibility. But now, with the Pandas network analysis, it's very easy, user-friendly, and quick to generate accessibility measures. We're using it not only for the forecast model, but we're also trying to use the accessibility analysis capability of new UrbanSim to do other analysis. I'm going to show you an example later part of this presentation. Output indicators. It has the new UrbanSim has the capability to link directly to UrbanCanvas, review spatial indicators instantaneously. And what we recently found out is this data frame explorer. Whoever developed that, it's a great help to us. It's a great tool for us to.
Smiling in the back.
Who did that? So it's very easy to use, and you can view your entire database in web browsers. Basically, you have your input data files, output data files, and link that to it, and you can quickly generate a map or a number of maps with different statistics, and you can do calculation, manipulation of the data on the fly instantaneously. We found that's actually a very, very helpful tool to visualize, particularly for explore the input data and see if there's anything wrong, we need to change something, and of course in future we can see how useful it is to develop or visualize the output of UrbanSim. Speed. In our last forecast, it took about an hour, 20 minutes, or 2 hours to finish one forecast year simulation with the 7-county area, 4.7 million people, 2 million parcels. With the new UrbanSim 2, our preliminary experiment shows that it takes about 8 minutes to finish 1 year's simulation. Of course, this is just for the current setup. We don't have the complete system specified yet. It could take longer in the future, but seems to me the new UrbanSim is faster than the old UrbanSim. So that's basically our experience, or really limited experience about the new UrbanSim. Then for the second part of the presentation, I'm going to show you one example. We use this new UrbanSim system to do some accessibility analysis. Transportation for America selected SAMCOG as one of the regions to for its initiates for integrating public health and transportation planning. Actually, I think they had a meeting, kickoff meeting here at MTC a couple of months ago to really promote using transportation planning for the benefit of public health. And because of that, SAMCOG formed a task force called Access to Core Services. We're having local elected officials, planners, other interest groups form a task force to try to assess the efficiency or the gaps in the transportation services to core services like hospitals, human services, parks, recreation, so on and so forth. So we used the new UrbanSim 2 in the last few weeks, 3, 4, 5 weeks, to did some quick analysis to see if we can use this system to do some comprehensive accessibility analysis. Guangyu and Surisha did a lot of work in this project so far. accessibility is really gaining popularity in the planning field and transportation planning field in particular, because accessibility is the ultimate goal of transportation, right? When we talk about accessibility analysis, we're thinking how we quantify different accessibility measures, and there's need to develop some common measures for comparison among regions, among places. It's actually lacking so far, not like the mobility measures. We do accessibility analysis to identify gaps where accessibility is low, so we can improve them. And eventually, we hope we can use accessibility to evaluate transportation and land use projects, solutions, in addition to some of the mobility measures like speed, level of services, or traffic flow, volume, those kind of traditional measures. Of course, the ultimate goal is to improve quality of life. We think there's some advantages using UrbanSim to do accessibility analysis. Number one, it's the speed of calculation. So far, we tried some both local accessibility measures and some regional accessibility measures, and actually we can use UrbanSim to do that for the entire region in about 5 seconds for 2 million parcels. Level of details, because UrbanSim has this very detailed database in it, parcel-based. It's good for some really small area local accessibility analysis, and you can also aggregate to do regional accessibility analysis. Comprehensiveness, multiple layers data, different networks, we can incorporate different levels of network into the system as well. We'll show you a couple of examples later. Since the UrbanSim system has both base year data and forecast data, there's possibility for easy comparison of base year accessibility and future accessibility if the transportation system changes. And here's the small town called Chelsea in southeast Michigan, and parts of the 4 townships surrounding the village Chelsea. These yellow lines are parcel boundaries, and then we imported or converted our most detailed road network called Michigan Geographic Framework, or MGF, into the UrbanSim system. So these purple lines are the MGF road networks. Of course, we know each road segment has 2 nodes, and then we use the UrbanSim tool to link the parcels to the network through these nodes. So now these colored areas are the node areas, same color parcels linked to one node, and then linked to the entire road network. And then from there, we do accessibility calculations. First, show you a, oh, okay, so just a few more illustrations. House there, hospital there, and they are linked to the network through the nearest node. Then you can do accessibility calculations based on whatever data you have by parcel and attributes you have on the network. When calculating local accessibility, it's really fast when the travel distance or time is actually low, like within the mile. It only takes a few seconds to calculate. But when that impedance threshold increases, it takes significantly longer time. So if we say within 15 minutes of travel time, 20, 30 minutes travel time, it gets much slower. So what we did is for measures like that, or regional accessibility, we switched to a different network. The travel demand model forecast network. The more detailed network, the MGF network, has 200,000 nodes, and this one has 20,000 nodes. It's 1:10 ratio. So this is much more simplified, generalized network, but it's much easier and quicker to calculate accessibility with this one. For regional accessibility, it only takes seconds to do a 30-minute radius search still the parcel level, now the node areas gets larger. So a couple of examples. One is a neighborhood or local accessibility analysis we did to retail services. It's pretty simple accessibility measure. It's a cumulative opportunity measure. So for every parcel, we count number of retail jobs within 1 mile distance along the road network. And we also used a linear decay function to emphasize things that are closer, are more accessible. And as I said, it took 5 seconds to do that. And here's the result. Accessibility map for Southeast Michigan. Darker the color, the higher the accessibility. If we show that 3D map, you can see really the malls are very, very, the accessibility measure is very high for those places. But also you can see some of the gaps in the region where accessibility is really low. Meanwhile, we have demographic data. This is the just total number of households in poverty by block group. Darker the color, higher concentration of households in poverty. And we overlay the two, accessibility and the demographic data, and we can actually do some analysis to see who are in those low accessibility areas. So if we zoom into the Detroit area, you see a lot of dark blue, high concentration of poverty, yet the accessibility to retail is quite low. And those are the gaps that can should be addressed through planning, either as transportation or land use. So we do some aggregation, identify the low accessibility areas. This one using a 20 accessible job, retail job as a threshold. Overlay that with demographic data, concentration of households in low accessibility areas. Zoom into Detroit, see the purple areas are denser housing areas or concentration of households in low accessibility places. You can certainly look at the different type of households. This is for low income, and this is for no car households, and this can be very useful when we do accessibility to transit, things like that. Another example is a larger scale. This is the access to hospitals. This one we use a different measure, which is just for every parcel. Let's measure travel time to the nearest hospital. Here's the result. The red areas are high accessibility areas. The blue areas are low accessibility areas to the hospital. The yellow area is really the places that there's no access to hospital within 15 minutes of driving time. Overlaying that with demographic data, total households, or households with senior. And then you could aggregate that from parcels to larger geographies. This is by municipality. We have 230 some cities, villages, and townships. It shows which communities have lower accessibility. Even summarize that to the 7 counties. Certainly, in this case, rural counties, Monroe has nearly 45% of households can't access the hospital within 15 minutes travel time. On the other hand, Wayne County has pretty good accessibility. Only a couple of percentage of houses can't reach hospital within 15 minutes of travel time. So what we're going to do next is we're going to have the first task force meeting on the 20th. We're going to present some of this to the task force and continue to do accessibility analysis. There are some questions so far. We don't think we can do accessibility analysis, transit accessibility analysis with the UrbanSim, the current form. What can we do with that? I said the Data Frame Explorer is a great tool for visualization, but can we do more with the UrbanCanvas? Then we'll really focus on developing our new real estate model, performance model. We'll finish the input data. We'll evaluate the data and model. And of course, task is to how we adapt the UrbanSim model to the Detroit region, which has its own challenges, calibration, evaluation, things like that. So that's all I have. Questions? Yeah.
This is really quite amazing, some of the things you guys have been able to do, and some of the analysis and simulations. What were you doing before this? Before you started Sim and why?
Drum impel.
Could you repeat the question for people who are attending online? They don't have like.
Okay, the question is, what did we do without this new UrbanSim? For the modeling, forecasting, we had a long history of using UrbanSim actually, starting 2001. We had 3 implementations of UrbanSim, from parcel-based to from grid cell-based to parcel-based to the current form. For accessibility analysis, we didn't do a whole lot as an agency. I was doing some of that, basically using ArcGIS. It's certainly it's much more convenient and faster this way with the new UrbanSim with its capability. Danny.
Yeah, and so in addition to the accessibility measures, you claim sort of using the traditional generalized cost function parameter for vacancy and time distance. Have you looked at any sort of composite accessibility logsum type measures? And I imagine if you could configure a similar process.
We're going to be talking about some of that later on.
We're not going to get that far. We'll have to read my dissertation. But it's in there.
The question from Daniel was, we have been using this more simplified accessibility measures like counting number of jobs or just using pure travel time. Have we used any more sophisticated measures like log sums or other accessibility measures? I've done that with ArcGIS before, but haven't done that with new UrbanSim 2. But if you have that in the database, right now we just have travel time, travel distance in the network. But if we have other, say, cost impedance measures in the network, we can certainly use that. If there's a, say, generalized cost of travel with either the more detailed network or the simplified travel demand forecast network, we can certainly use those kind of measures instead of just time and distance. But Fletcher has more.
If you remind us when we talk about bandana, ask the question again, and I'll do my best to answer in 15 minutes.
And I'll ask the transit question again.
Yeah, sure.
Dimitri.
So your accessibility measures, are you using the same network that you have that you use for the travel demand model, or it's something entirely different?
The second one is. So we so far we converted 2 networks into UrbanSim 2. The first one is called Michigan Geographic Framework, MGF, which is not the travel network. It's more detailed. It has local streets on it as well. The second one I showed is actually exactly the same of the travel demand model forecast network. It even has the feeder links in there. We debated about that. I mean, there's some details I didn't talk about. You certainly don't want your parcels joined directly to freeway nodes, right? So people don't just get onto the freeway immediately from the adjacent parcels. So we actually did this in 2 steps. When we joined the parcels to the network, we excluded the freeway nodes. And then when we do the accessibility calculation, we had the full network to use.
Also, from the public health perspective, is there significance to the 15 minutes? Why not 20 or 30 years?
No. We can do any. With the speed of the system, we can experiment with different impedance measures or threshold. Do you have a suggestion, Dimitri?
No, I'm just asking about 15 minutes. I mean, seems awfully short.
It is.
I would be looking at something.
Yeah, there's some other things that I didn't talk about. The edge effect. Actually, the system doesn't know anything outside the region. So there's some hospitals out there. So accessibility is actually better than what we show on that map. All right.
Thank you very much.
Thank you.
So, Jesse? Got a team presentation.
Not sure if I should close that or not. I think we can close this one. Red button. Yep. Thanks. Down button. Very good. Okay. I'm Jesse Ayers, excuse me, with the Maricopa Association of Governments. I'm here with Scott Bridwell, who works real closely with us, and Hanyi Lee over there. Met most of you over time, and looking forward to meeting a few new faces that I see here today. Also know Anna Bob Bagley, who we work with pretty closely, and I'm sure he's pretty familiar to you all. So today, we're going to talk just a couple of slides about the MAG region, just for those of you who aren't terribly familiar with the Phoenix area, slide or so about the most recent set of projections that we did using the Opus version of UrbanSim. A little bit about our past, present, and future of the models and how those were set up, some of our AZ Smart tools that we've developed with some consultants, and a little bit about the Opus model structure that we used before, and then Scott's going to take over with some comments about the new code and some models that he's implemented for us that are straightforward, but I think pretty useful. Hope to get those checked in the next few weeks. So real quickly, the MAG region is 9,200 square miles of Maricopa County, and Maricopa County is the gray line there marks sort of the southern boundary of it, and we've actually recently expanded, added some new member agencies in Pinal County, so we now have this whole red line area as well. So we're expanding with some new member agencies, and that's certainly creating some challenges, but not only with the modeling, but in other things too, just data collection and things like that. They actually overlap with an adjacent cog. Excuse me. So we are expanding, not only in population, but in our jurisdiction. These are the control totals that we used for the last set of projections, just for Maricopa County, going from 3.82 million, roughly, resident population until the 2010 census, up to 6.17 in 2040, and about 1.7 million jobs, up to 3.1 million jobs in 2040. And we're tracking really closely with this. With our most recent 2014 population estimates, we are actually hitting almost this total for 2015, just over 4 million. So this is actually, we're actually a little bit ahead so far. And these are just a couple of maps of the last set of projections, just concentrations of population and employment. This is the 2010 version, and 2020, or 2040, I'm sorry, I skipped right up to 2040. And then the same thing from employment concentration in 2010 and up to 2040. And these are based on the results of the last set of projections, and some of our GIS folks put these maps together for us. Moving on just a little bit here, doing modeling like this for quite a long time at MAG, well I arrived there.
just put a few of the last sets of projection series on here. Prior to my time at MAG, they were doing using a system called SAM-IM with DRAM-MPAL. 2007 and prior, I think they used that going back to the early and even early 2000s and late 90s. And of course used DRAM-MPAL for many years before that. SAM-IM was a custom system developed for us by a consultant that was grid cell based. Excuse me, and that heavily influenced our implementation of Opus. And then I came on board at MAG in 2008, and that's when we started using the Opus system. And that was successful for us. We completed the last set of projections in 2012, 2013. This is something that we do every 4 or 5 years. As you can see, there's some, we usually base it on a census if we can. In 2005, they had a special census done. The 2010 census, of course, is the last base. And then 2015, there's a lot of talk right now of what the cities are going to do to figure out their population for 2015 and what we're going to base this on. So we're moving ahead for a lot of the advantages of the new UrbanSim 2 that have already been talked about before me. We're going to move ahead with UrbanSim 2. Our projection series, we get control totals from the state demographer's office, and we have to use those at the county level. That's something that we're stuck to. But below that, we do all of the allocation from there. Excuse me. And we expect to get control totals from the state demographer late next year. If it goes like last time, we'll get them sometime probably in December of 2015, and then we'll be off and running. Once we get those control totals, we have about 9 months to do all of the sub-county modeling, and we also have to get it through the political process in that time too, so we have to get the buy-in from all the cities in that same time frame. So it's a pretty tight time schedule once those control totals hit. That's all an executive order from the governor's office. And as you can see over here on the right, the challenges have remained the same no matter what system we're using. Base data issues, I'm sure everyone is familiar with. It's really challenging to put these databases together. Tons of data issues from all these different sources, parcel, assessors, just you name it. It's a difficult thing to put together. Real estate development is a continual challenge for us. We're looking to implement the new real estate model that's up and running now. And I think we're looking to do some improvements to that through a contract with Synthicity. So we're looking for some feedback on that too. And finally, these are probably the most important issues that we face, but there's a whole bunch of other ones. Incorporating member agency feedback in that political process is a really challenging thing for us. It's something that we have a little bit of control over that process. We have a really good relationship with our cities, and but the time frame is so tight, and it's just a really challenging thing for us to do. I mean, ideally we would rerun the model every time, but there's not always time to rerun the model in that 6 month or so time frame that we have. So AZ-Smart, I spoke of that a few minutes ago. AZ-Smart is just a system of tools that we've developed over the years, either in-house or through consultant contracts, that help us get data into the urban simulation environment and back out of it for analysis. And so this is kind of a complicated looking graph that shows an awful lot of data inputs that we have. They vary from Excel-based spreadsheets, shapefiles, feature classes, and all these different things. We assemble all these things into a database, a SQL database, and then we run these things through some different tools. Any of these sort of teal, blue boxes on here are some kind of tool or process that we've done in the sort of AZ-Smart framework. Any of these tools, these are written in various things from VB.net, plug-in types things to ArcGIS to just basic SQL queries or Python tools. It's sort of a hodgepodge, if you will, of different tools we've developed over the years. Some of the most important ones are where we take employment control totals and link them up to building records. There's a tool we've developed to help us do that. Same thing on the population side. We've been using ASU's PopGen, I think is what they call that. Is that right? PopGen. We use that to get population down to the block group level, and then we have an AZ-Smart tool that helps us locate that population to building records. And take all that and put it into the parcel level database. And from there, we have a parcel level database, that's presumably as good as we can make it, at least in the time that we have. From there, we would, if needed, we would aggregate the geographies and built space into, at least last time we did this, for a zone level model system. Bring it in, cache it, run it through UrbanSim, and then back out to, last time we brought it all back into SQL, all of the simulation results back into SQL and used mapping tools from there in ArcGIS. And this is how we put the last set of projections together, the different models. Starting at the top, the demographic model up at the top, that was run by the state demographer's office. They did that by county. It was a cohort survival model that gave us all the population projections going out to 2040. The regional economic model, this is something that we're working on now. Last time we purchased a set of projections from Moody's economy.com and did a little work on those in-house by our regional economist to help match those up a little bit better with local conditions. We're starting a process with Sandag right now to develop a regional economic forecasting model for us and Sandag. And this is, Sandag has had one for a long time called DEFM, and we're looking to improve on that. Something that they like and they've had a lot of success with. And we're looking to not necessarily rewrite DEFM, but make some improvements along the way. And hopefully we can get that done in the next year or so, at least a version 1 of that. So from there, we would take these control totals going out to 2040 at the county level, run them through an OPUS-based model system, is what we did last time, down to a geography we called market areas. It's an aggregation of traffic analysis zones. I'd say there's probably 5 to 7 TAZs per market area, roughly. In Maricopa County, I think we ended up with about 160 market areas in Maricopa County. And so we would run this mid-level system, if you will, all the way out to 2040. And this was a really fast model system, and we could do a whole 2040 simulation annually in probably, I don't know, maybe 15 minutes or something like that. And this is something that we were able to, rapidly iterate on, and we liked this. This type of mid-level modeling has a long history at MAG, so it's one of the reasons we did that. And it helps us solve some of the challenges that we have. We have an awful lot of capacity for new dwelling units, and it helped us quite a bit. It also created its own problems, and it's something that we're looking to maybe improve upon next time. Maybe we can go from the county all the way down to the parcel. We're going to have to see, but hopefully we can do something like that. So then once we got pretty happy with the market level results that we got, we would use those then as control totals and run another OPUS-based model system, market area by market area, and locate things down to what we called super parcels. They're sort of neighborhood level, like single-family subdivision level parcels, aggregation of assessor parcels. And this was mainly for a performance thing, and it worked out pretty well. We could do pretty decent accessibility calculations at the super parcel level, and I think this worked out well. I think it's something that, again, we're going to try and improve upon this and go with the parcel level detail this time. We're getting asked lots of questions from our member agencies that I think could, we could develop better answers for them with a little bit more detail. So that's how we did it last time, and I think this is where we're going to move on to our experience so far with the new UrbanSim code, and Scott's going to take over here.
Okay. So at MAG, we've kind of looking, we got done with our last forecast series for the most part, I think, last summer, and we had some final input analysis or some output analysis that we've been doing up until last year. And so in looking towards the future, what we're going to do with the next forecast series, there was a lot of discussion and debate about which direction do we go. Do we stick with the Opus code that we've invested a lot of time and energy and have a pretty good deal of expertise in, or do we move on to the new, I guess we've been calling it new UrbanSim or UrbanSim Pandas version. And I think for a while there, we really were leaning towards sticking with the old Opus code, at least for this next forecast. But I think that we started to recognize that we needed some significant changes in how the real estate analysis and modeling was being performed. And since we were going to invest some time and money into that, we might want to invest in the new code itself. And so I think probably around July or so, we really started to hit the new code pretty hard, start testing it, evaluating it, figuring out what potential changes are we going to have to make to it in order to fit our own model needs and structures. And a lot of this, so we've basically started out from the basics, learning kind of the new platform itself. So that would be pandas, has been talked about before, but also the source control environment was completely new to us as well, the whole GitHub environment. Traditionally, we have used a very centralized source control, using, I guess, Subversion with the Opus code. And then also all our AZ Smart tools are all .NET tools, and so we use Team Foundation for that source control. So we spent some time trying to get a handle on Git and also get a handle on the unit testing environment in terms of how do we use PyTest to actually write these tests, what does it mean to have coverage, having things like Travis CI actually run these tests and do all those types of things. And also getting used to using like IPython instead of using the GUI. And so far, our experiences have been really positive, I think. The pandas data structure is really great and it's really flexible. In a lot of ways, I wish that we had something like pandas in .NET. You know, I keep searching for some pandas-like functionality in .NET, and it just really isn't there. So it's pretty impressive. In terms of the Git and the source control, that's another thing which I think we had some hiccups along the way, and we're still kind of getting there and trying to figure out exactly how we want to structure things. But we're moving along, and essentially what we have right now, we have a MAG organizational level GitHub account that we have. There really isn't a whole lot there right now. It's kind of a placeholder more than anything. And then the three of us, me, Jesse, and Hani, we all have our own personal accounts as well. And we also have forked the Synthicity repository. And in doing that, we basically tried to look and see which features are missing, basically. What are the core things that we have to really have done in order for us to move on and actually employ this within a forecast. And in doing so, we've also tried to look at the new Proforma and the new real estate models and try to assess what are the new data needs, data preparation needs, what kind of other factors are we going to have to collect and that kind of stuff. And so I'd like to talk a little bit about some of the features that we've kind of begun re-implementing. The first one, which really kind of got our hands dirty in terms of using Git, using pandas, trying to actually make contributions to the Synthicity repository, was that one of the things that we require is to hit total population controls exactly. And so the transition model was transitioning households, but the Opus accounting attribute wasn't necessarily implemented within that, so that's something that we implemented and contributed, and that was kind of our first foray into actually making a contribution to the code. So the next thing we want to do then is actually write a model from scratch and see how that would go. And the model that we decided to re-implement from scratch is a pretty straightforward model. It's simply a prorating allocation model. And so this really isn't a theoretically elegant or sophisticated model, but it's kind of a workhorse model that we use for a lot of different things. So really all we're going to do is we're going to try and take some quantity and distribute it to some other sets of rows, or we might take a set of agents and locate them based on simple weights or shares. And so this could in a way be kind of like a lightweight location choice model for cases in which we don't really have necessarily data or information about the process, but we need to get something done. So in terms of the old Opus code, how this, I guess, comparable models would be the allocation model and allocation model exact, which actually do quantity allocations. And then in terms of agent allocations, things like scaling jobs and capacity location choice model. And as I mentioned, we use this for a lot of things, and a lot of these are things that we don't necessarily want to spend a whole lot of time on, but we have to do. So for instance, things like group quarters populations, those are things which work really well. What we do is we maintain a series of columns on our buildings table, so like a group quarter population for different categories, and then we then use control totals to essentially distribute and grow those in place. We do a similar thing for transient population, so we do population in households, or transient population in households and also within hotels. And then we also do construction jobs and on-site based jobs. These are, again, are quantities that we keep at either the building or the parcel level. And then in terms of agents, we also do seasonal households. And again, we don't have a lot of data or a lot of knowledge about how seasonal households locate. So we use a simple weighting process to locate those. And we do the same thing with public jobs. So what we tried to do is we tried to take essentially the existing Opus models and reframe those into two models. The first being an allocation model, and this is just a simple quantity allocation. So again, we have an upper level control, and then based on a set of weights or shares, we're going to distribute those to another set of rows. And the way that we have this implemented right now is it's basically going to return a pandas series with those allocated quantities to it. And so a simple example of how we would use this is, given a control total for tourists, assign the number of tourists to buildings based on the number of hotel rooms as a weight on those buildings. In terms of an agent allocation model, we're going to basically take a set of agents, and from those agents, we're basically going to infer control totals from those. And what the model is going to do is it's going to return a pandas series that has the location IDs of where those agents are actually going to be located. This could be a building ID, it could be a parcel ID, and it also will return the allocation quantity results as well. And so an example of how we might want to do this is to assign new public jobs to buildings based on the existing public jobs that are there already. Information about how public jobs actually locate or make choices, then we might actually just try to grow those in place over time. So here's some of the objectives that we wanted to have with these models. We want to make them really flexible, so we want to be able to run them with or without weights. Also allow them to respect capacities or run unconstrained. We wanted to make sure that we hit our controls exactly. We want to be able to allocate both totals and changes. So we might want to allocate totals for something like construction jobs, in which we assume that the entire distribution is going to change from year to year. But we might want to distribute just the changes for something that we want to grow in place. So for instance, something like a group quarter population, we might want to maintain the population from the year before and just allocate the additional population that's coming in that given year. Also, we want to support basic segmentation. So this can be segmented by geographically, by TAS or sub-area. We could also do this by job sector, the types of things. Really any kind of segmentation, just like you would with the transition model. And then also, I don't know about other regions, but handling declines is always a problem for us. It seems like things that you're losing and declining always present problems. For instance, like taking quantities negative and that kind of stuff. And so we want to be able to do this fairly elegantly. So I'll just give you a couple examples, simple cases of each of these models, and also show how we have this implemented within the simulation framework. And so the first case here we have is a simple theoretical allocation example. And what you have on the left is the actual Python code that would be used to both initialize the model and then also run the model in terms of a simulation. And on the right, you have the data inputs. And so the first data input there is essentially a control totals table. And what you have on the left there is the index. So it's indexed by year, just as a transition model control total table would. One difference between this and like a transition model is that the transition model, I think, is assuming that all columns besides the total column are essentially segmentation columns. And one thing we wanted to do with this was make it a little bit more flexible so that you could basically have multiple columns within the same control total table, but you could then pass in which columns you want to segment on. So here we have basically TAS serving as a segmentation column. And then the next table, then we have some other table that we're going to try to allocate to. Again, these could be parcels, these could be buildings. And so here the index doesn't really matter, that's on the far left. But we have our TAS, which is identifying this segment. We have a weight. We have a capacity that needs to be respected. And we also have an existing column. This is the row that we're actually trying to allocate to. And so in terms of the model, then the inputs that we're going to pass into it in terms of the initialization, we're going to pass it the amounts control total table. We're going to tell it what is the name of the column that is being allocated. And then we're then going to tell it in terms of the table to allocate to, what is the column we're allocating to, what is the weight column, what is the capacity. Are we forecasting changes or totals? That's the as delta. And then this compute delta basically indicates if we're going to compute change from the control total table or if the control total table represents change already. So that's in terms of the initialization. And then in the simulation, basically, we're going to pass it a year and then a set of rows that we're going to allocate to. And then, like I said, with this is going to return back a series, and then that resulting series can then be applied to the data frame to actually get that. Okay, so here's nitty-gritty code. This is an example of how this actually gets implemented in the simulation framework. And actually, we took some liberties with the simulation framework within my fork, because here we have defined a model as a class, not a function. And so the reason why we did this is that we wanted to instill a lot of the initialization logic and not have to repeat that multiple times. And so what we have here are basically two allocation models within one model. We're calling this a transient population model, but we are trying to allocate both population in households and also population in hotels. And so we have these set up, and we have a series of columns that we are using to actually initialize these models. And these columns actually are injectables that are defined elsewhere within our file. And then within this def call, this is where the actual simulation is occurring. We get a copy of our buildings data frame. We then apply the model to then update each of the populations we're trying to allocate. So then in terms of the agent allocation example, what we have again are two inputs. So the first input we have is our locations table, and these are basically, we're going to assign the indexes from this table to our agents. And so to initialize this, we're going to then basically tell it what is the name of the column for the existing, and this is important to maintain capacities, and that's essentially the column that we're allocating to. We're going to tell it what's the weight column on the locations table, what's the capacity column on the locations table, also what are the segmentation columns that we're using. And then to simulate this, then we're going to basically pass in the locations table for that year, the agents for that year, and then the year here isn't really used, it's just kind of a placeholder, I guess. And so what this is going to do is it's going to return back, again, two series. It's going to return back the actual location IDs from the indexes in the locations table to the agents, and then it's also going to return back the allocation results on the locations table itself. And so you can see here, the red is supposed to indicate basically the results. And so on the locations table, you'll see that as a result from this, we've updated the allocation column to show the most recent allocation of the agents. And then the agents themselves are then going to all have location IDs. And you'll see that we started out before this with no location IDs. And after that, the majority of the agents are assigned a location. There's a couple of the agents that are still left as unassigned because there wasn't sufficient capacity in order to assign them. And so this is how this might be within doing our public jobs. And it has a really similar structure to how we did the tours. Again, we define essentially the initialization of the model in the init in the class. And then what we're doing then within the simulation is we're getting access to the buildings table, we're getting access to a jobs table. We're then filtering out just those buildings that are public based on a building type. We're filtering out just those jobs which are public based on a NAICS code. And we're identifying just those jobs to locate based on those that have unassigned IDs or null IDs. And then when we get the results from that, we then basically update the buildings table with the allocation results. And this is important in order to respect capacities because it'll then be fed as input to the next loop, the next year, I guess. And then the jobs are updated IDs as well. So those are some of the things that we've played around with thus far and really trying to get our hands dirty with the new code. Kind of where we're generally going from here. As Jesse mentioned, a lot of our logic in terms of how the data actually gets structured is done outside of Opus or outside of UrbanSim with a series of .NET tools that we have. And so we're trying to improve some of those tools so we have better data validation. We're also trying to reevaluate some of the data structures that we have, particularly at the level of aggregation. So in the last round, we aggregated parcels up into super parcels. And we're looking at whether or not we want to do that again, or if we want to use parcels as the base source. We're also potentially looking at cutting parcels into smaller pieces. In Maricopa County, we have really big parcels, especially in master plan communities, and those become really problematic for allocating real estate. And so we're looking at some thoughts about maybe tessellating the parcels themselves, sort of like a gridded parcel, I guess, in a way to try and handle some of those things. So in doing this, we're also looking at what additional data sets and how do we incorporate our planning data sets so that we can use the square foot pro forma analysis. And then also another issue that we're grappling with is that the cities, their general plans are becoming increasingly ambiguous. So instead of having land set aside for single family residential or retail, they'll define a big swath of land as market-driven land use. So basically, I think the quote that somebody gave us was that you guys are treating our general plan as though it's predictive, but it's not. It's basically, it's prescriptive. It's basically saying these are potential things that can go in there, not what's actually going to go in there. And so we're trying to basically figure out what does that even mean in terms of things like build out, and what are the capacities within our model. So we have a whole set of stuff that we need to deal with in terms of our base data tools. And some of these things we might actually move from .NET into more pandas-oriented tools just because we really like the data structure. In terms of where we're going with the simulation, we want to do some more, we want to do some testing with the location choice and price models. We haven't done a whole lot of that. I know Jesse and I have both looked at the San Francisco UrbanSim example, which has been a tremendous help in order to understand how the whole structure works. So we're trying to basically, we've looked at the price models and the choice models within that, and now trying to figure out how do we incorporate those with our new data. Also, we're basically looking at the UrbanSim developer model and trying to figure out what kind of enhancements do we need. I think the one major enhancement that we know we're going to probably need is some sort of a phasing component so that not all the units get necessarily built at once, but maybe they get put into sort of a developing or active development pool that then comes in and actually does the development itself. And then we're also looking really at what does the overall model system flow in terms of when things happen. Do we do a choice model and then run real estate? Or maybe do we structure the choices slightly differently? Maybe agents choose the type of structure that they want to live in. Then we have a development model that responds to that demand, and they choose a specific location after that. So there's lots of different ways that we can think about trying to structure these things and what the implications of those are. And then the last thing is really just the overall review process. I'm sure that all you guys deal with sort of negotiated forecast issue and how do you actually incorporate feedback. And so we're trying to figure out basically how can we change our review process to make it easier to incorporate feedback, and also potentially write some new tools that make it easier for us to incorporate that as well. That's all I have for you.
Take any questions.
I'm sure you'll have some questions.
Scott, can you walk me through a little bit of that constrained allocation process you developed?
Sure. Yeah, I went through it pretty fast, I guess. Okay.
So at this point, you're trying to allocate households to a zone. I guess I'm curious, first of all, what is your capacity? It's obviously known a priori.
Yes.
Can't have negative vacancy rates.
Right. So a concrete example of this might be, again, getting back to the tourist example, because I don't think, in theory, you could apply this for something like households, but probably this really is what we call these ancillaries. They're sort of like non-core things that we really have to do, and they're kind of a bummer because they require a lot of time, actually. But in terms of the overall kind of regional pattern, they don't really contribute that much. And so a good example, I guess, of this would be group ordered population, right? So group ordered population, we have a control for, let's say, dorms that we're going to have. And so some of the inputs to that might be, let's suppose that the universities gave us specific dorm level facility information that told us essentially what the capacity for students could be within those dorms. And so that's essentially what we'd use for the capacity in that case.
So for like households to zone, you're just asserting long-term average vacancy rates.
I think even aside from, I mean, these are really, how would I describe these? These are really tightly constrained models, I guess.
And theoretically, you could use them to allocate households to dwelling units. I mean, you could do that. We haven't done that. I mean, you could theoretically set up an entire model system around these two models if you'd like. I think.
In a lot of ways, this was an exercise that basically how do we work with the code? You know, pandas with NumPy, with all these types of things. But it also is something which we're going to use for a lot of different things. And we might potentially try to look at households. So you could do like zonal households based on a vacancy rate that could provide your capacity, and maybe your weight is something as simple as the density that's there already.
Or that. Vacant units. Or
vacant units.
Something along those lines, yeah.
Have you done a similar process for your developer model? I know it sounds like you're just getting started and exploring the new developer model.
The old developer model was a... Yeah, the old developer model, it did require specific capacities. that we computed the capacities off of the general plans or known development projects is how we did it before. So we would have a super partial level capacity for dwelling units, and then we would use a developer location choice model, the developer seeking a site type model, where we would have a development, it had 50 units, say, where do I locate? And then following that, we would have a household location choice model that would come in and locate households into those units. That's how we used to do that. Yeah.
I mean, I think our recommendation, or not our recommendation, but our ideal case would be to use the multinomial logit choice models to do things like households.
Right.
Things that we actually can get good data for, and we feel we can capture that process a little bit better and actually model it. And these would be things that we don't necessarily have these types of things for. But we could use it for like household location choice model, I think, is a baseline. Jesse's talked about doing this. So for instance, just in terms of testing, if we're trying to just test the real estate model, it gives us a nice common way of implementing that quickly and having at least a placeholder for that as well.
We will definitely use these models for the columns that, the travel model requires, transient population and group quarters population, like you said. These things that we have to do that we don't have good data on to estimate a real logit model for. But we could set up and do a test model. It's also good just to learn with. I mean, we learned an awful lot about just Git, GitHub, the simulation framework, all those things. This could be used in a classroom environment. So there's a lot of use for these kinds of simple models.
This approach, so I will say the last thing, this approach is pretty attractive though. So you guys identified the challenge of just allocating an increment or delta, giving you stability between time. That's something that we've always struggled with.
Yeah, this model is pretty much deterministic.
It is.
Except for the rounding process.
It's true.
So the rounding process is a stochastic weighting process. Basically, everything gets rounded down. Then fractional components are used as a weight, and we use a random choice to then get the number of units that we need to hit the total. So, and in most cases, I would assume that's trivial, probably onesies and twosies here and there. But if your weights were really small, then I guess it could make it effective.
And this will be checked in for everybody to use. And Fletcher and Matt, you guys can expect a pull request on this in the next couple weeks. Yeah, go ahead.
So you guys actually started using the new code by yourselves?
Definitely.
And I think you're probably the largest section ever. How's it going? Like, a lot of times open source development is kind of a one-way street. I want to hear how it went. Like,
let's go back to this slide up here.
Sort of glossed over that a bit. What are your frustrations and pleasures? And
here's one of my builds that failed.
Yeah.
So let's see, our impressions, I think they've really been positive. Yeah. And, I don't think any of the three of us are really developers per se.
None of us have formal training.
We're all sort of self-taught. Like, we're geographers that develop, basically. And so, we always test all the stuff that we do to the degree which we can. But the level of rigor in terms of these tests is definitely beyond something I've ever done. So just to give you an idea of that, I think that there's actually more code. So the allocation model is implemented, and there's a series of tests which are implemented. It has 100% coverage. And for those of you guys who haven't played with this yet, coverage basically means that you write tests, and it measures the number of lines that are covered by your tests versus the entire code. And so basically the tests cover the entire sequence of code, and there's like 400 lines of code for that. So there's more code in the tests for the allocation model than there is for the allocation model itself. And which was helpful. I mean, it definitely identified bugs, and maybe sort of rethink the process a little bit. But that took a little while for me to get my head around how to actually do that. And I think that when I made my first pull request for the transition model enhancement to do the control to an accounting attribute, I think that I had no idea about any of this. I wrote the code, I didn't have any tests. I pushed that thing up, I didn't know what coverage meant. And then all of a sudden I had all these like PEP8 failures and stuff. Like I was kind of frustrated because I was like, I'm trailing white space and this thing won't take my code, So once I got over all that and kind of found the tools that I needed to use to check my code, then I got over it. I think it's think it's an improvement for sure.
You know that is, I have to get them past Matt. It's not always
Yeah, I've seen some of those discussions. Yeah.
Yes, definitely. I think overall it's been really positive. Git and GitHub has been a little challenging since we're used to the Subversion type repository, so that getting our head around the distributed way that Git goes about that has certainly been challenging. And if I don't do this quite as often, so it seems like I'm relearning that since I'm only doing these kind of check-ins maybe every couple of weeks or so. So I find myself relearning Git commands, but I'll eventually get there.
The only I think the one issue we've had is basically we're sort of a SQL shop, SQL Server shop, and as Jesse showed in that diagram, that's essentially where all our model results end up. And then we really hit that hard. Like we've written tons of queries that generate reports and do all sorts of things that we do. And the one thing we've had an issue with is just getting a pandas data frame back into SQL. It's really difficult, actually. It's super easy to read one in, but it takes a long time to actually push it back in.
Yeah, we haven't tested the new 0.15 version of pandas yet. I think they may have made some improvements on that, so we haven't done that yet. Hopefully they have.
Yeah, in relation to that, the other thing we did is that we're an Esri shop too. We don't have UrbanCanvas right now. So we've written some hooks, basically, that will go from a file geodatabase to a pandas data frame and from the pandas data frame to a file geodatabase. And so what we've kind of been doing is taking those outputs, sticking them into a file geodatabase instead of the HD5 file, and then going from there to SQL Server what we need to instead.
All right. Thank you very much. So our last formal presentation is Hanna Shevchikova, was the lead author, really, in the previous implementation of UrbanSim, the open source implementation, and just remembering back to the time when we started that effort. Let me get this out of the way. So you can probably do this easier. Yeah. Just remembering back to the initial version of UrbanSim written in Java, we had some terrific software engineers, and they wrote amazing Java code for the UrbanSim implementation, and it was quite efficient, actually, for Java. But we got to a point that we had a kind of contractual relationship between modelers and developers, in which for modelers, that is, more end users, like we just heard, to actually get new variables implemented or new models implemented, you had to write out detailed specifications and negotiate with the developers to get that implemented. And it was too much of an arm's length relationship. And I think we had really the dream that modelers at client agencies using UrbanSim could write models and could write variables and so forth. Then we made heroic progress in that in the Opus implementation, and we got a long way down that pathway, and I think it served us really, really well. And getting a new generation of people involved in the project, like Fletcher, Eddie, and so forth, they weren't quite ready to roll up their sleeves and learn all of that code, and so we sort of have gone through that again. But it's been quite a fascinating journey so far. So I think Hanna's going to talk about some work on uncertainty that is the most cutting-edge work on trying to analyze patterns of uncertainty using urban models.
Yeah. Thank you, Paul. Okay, so I work now at the Puget Sound Regional Council in Seattle, and this work, assessing and integrating uncertainty into land use forecasting, is a joint work with my colleagues Mark Simonson and Michael Jansen at the PSRC. It is based on a paper that we submitted to the Journal of Transportation and Land Use, and I also presented a similar version of this talk at their conference in Delft, Netherlands, a few months ago. So this is the outline. So I talk very briefly about how we use UrbanSim at PSRC. I describe briefly the methodology of assessing uncertainty, but the focus will be here on the application and then integration into the land use forecast. And then I also talk how we use the uncertainty in our everyday modeling, like scenario testing, and I conclude then with some news from the PSRC modeling lab. So this is our region, 4-county region, with Seattle, the largest city, in the middle. And we predict at 2040 that there will be almost 5 million people and almost 3 million jobs. And as you can imagine, we try to spatially distribute those agents across the region. This is the basic UrbanSim settings at PSRC, and many of you saw this slide before, at least the setup of the models. So I'm not going to explain the models. It's a standard setup. What I want to emphasize is actually how uncertain these models are, that we have a couple of models that are estimated, like with hedonic regression or logit models. These coefficients are uncertain. We have a couple of models that use random sampling. Again, the stochastic models are uncertain. In addition of that, so these were input parameters, stochasticity. We have errors in input data, as I think Jess mentioned here, and also model structure. So we don't know if the models themselves do the right thing, right? So nevertheless, usual forecasts of outputs of forecasts of land use models are point prediction. So this is a screenshot of our previous forecast. So we would have the indicator on the left-hand side, and the actual and the forecast numbers on the right-hand side, and each of those would be just right numbers. You know these type of projections. So what do you think that the probability is that in Seattle Center in 2040 the total population will be 24,773? It's probably 0, right? So we have 0 probability of these numbers, but nevertheless we would publish them and give them policymakers to base their decisions on them. So we wanted to overcome this. So in the past, we developed with Adrian Rafter and Paul, we developed a methodology, statistically grounded methodology for assessing uncertainty in urban simulation called Bayesian melding. And I said this talk is not actually focused on the methodology itself because it was published previously, but I very briefly describe how it goes. So we have our model that's a black box for UrbanSim here. We have our starting point at which data go in and some input parameters. We run the model. We can run it multiple times until a time point that we call here present time. And the present time is the time point when we have some observed data available. So we denote them here by Y, and by combining the outputs of the models at the present time and the observed data using a likelihood function, we get weights and a few more other quantities that I describe later. And using this information and output of the model, when we run it into the future, when we combine those, then we get a posterior distribution of the quantities of interest. So this would be the resulting formula. I heard somewhere that you lose, for each formula that you use in your presentation, you lose 10% of the audience. So, but you don't need to really remember this. It's really just I want to explain how this actually works. So the posterior distribution of these future quantities of interest is a mixture of normals, so sum of normal components, and each of the normal components is centered around the outputs plus some bias term. And we have here a variance term, and I describe this a little bit on the next slide. So this is the same formula, so this is not a new formula here. So we index over i's. I's are the multiple runs that I talked about. K is the geography, so this would be a quantity for example, zone, and L is the index of a quantity of interest. So for geography, we use traffic analysis zone, phases, or large areas. And so here I will tell you how we actually apply this formula. So so what we do, our starting time is 2000. So we have parcel level input data that go in. We run our UrbanSim until 2010. By 2010, because in 2010 we have observed zonal data on households, population, and jobs. So these are our indicators. That's the L index. And because we have observed data on this level, we get out of the model the same quantities. So our outputs from the model, from UrbanSim 2010, we get it out on the same level. And combining these two, we get the variance term, bias term, and the weight. And I put here on the right how actually the variance is computed. And this should actually demonstrate what the variance represents. So what it is, it's a squared average of the observed minus the simulated. So basically it gives you sort of the distance from the observed and the simulated, okay? So the larger this sigma here, the farther we are from the observed data. Yeah, that's what this shows. So, and these have kind of straightforward formulas that are in the paper, so this is nothing complicated here. So you can very easily compute those. So what you get here now in blue, what you get here, and you just plug it in here, and then you run UrbanSim forward until your future time. You get the indicators on the same level as here. You plug these in. What is missing here, what we don't have, is this B, these B terms, and this F. So this is a propagation factor. Basically, we are estimating these quantities at 2010, but applying them in 2040. So we know they don't stay the same until 2040. So we need to somehow propagate forward. So how do they change over time? We estimate that by getting these quantities at an additional present time. So that's what this says, these B's. We have data at 2008 in our case. We get the same quantities in the same way, and look how they actually change over time. So we get the annual change for these, and then we apply and plug it into this. And as a result, what you get is a theoretical distribution of each indicator on each zone, right? That's what this is. And having the theoretical distribution, you can derive any quantiles from that, and that means any confidence intervals. So next things we investigated was how does the random seed influences these results? So, and meaning how many runs actually do we need to do? I had this I index, so how many times we need to repeat this. So this plot compares a simulation of 6 runs versus 1 run. And on the x-axis, we have phases. And each of these dots is for households and job, the result from the run, okay? And we have here 20 phases. On the left-hand side is a phase that has the largest difference between the outer dots here. And on the right-hand side is the smallest difference. So they are sorted, the phases are sorted. And all the other 200 zones that are not shown in this plot have smaller difference than this one. So these are the 20 zones with the largest differences between the points. And if I use Bayesian melding using 6 runs, I get the red error bar, and these are 95% confidence intervals. And the blue bars are when I apply it to just 1 run. So what it shows actually that we have few zones for households 1, for jobs maybe 4 or 5 that are a little bit different. I'm comparing the red bars to the blue bars. All the other remaining zones have very similar confidence intervals, and that would be the case also for all the 200 that I'm not showing here. So this shows us actually that if we are prepared to suffer a little bit of accuracy for 1 to 5 zones out of these 200, we can go away with just 1 run, and we can get pretty good approximation of the uncertainty. But it also shows that if you would not use Bayesian melding, if you would just base your uncertainty on multiple runs, just very random seed, you would have just the dots without the bars. It would greatly underestimate the uncertainty. And the reason is because the variation that you have just in the dots comes from the stochasticity, which is just one source of uncertainty. But the Bayesian melding catches actually many other sources. So this is a good news for us because we can just have one run and do the whole uncertainty analysis. How do we use it? So we used it in our official land use forecast, and it actually turned out to be very useful in all stages of coming up to the official land use forecast. For example, in the stage of evaluation of model runs, you probably know this tedious stage where you do different runs, you try different specifications, different model structure, different inputs, and then you try to compare those results. You get vast amount of data, and then you somehow try to evaluate which run is actually better. So this gives us, so the uncertainty framework gives us actually a nice tool to do that, because we have this variance term that I explained, the distance to the observed data. So basically, the smaller the variance, the better is the setup of the model. You can use the various runs as kind of multiple runs, right, the I index. So another thing is the weight. So the variance is computed for each indicator, L, like population or jobs, you could have different variants. So you can have a case where one run is better for households, the other run is better for jobs, but the weight actually combines those and gives you one measure across all indicators. So you could use that. We also used uncertainty in output review in a refinement, and of course then in the publication of the forecast that I'm going to mention on the next slides. So I think Mark Simonson showed this last year, how we used the uncertainty, but I'd like to mention it again. So what we did is for each zone, or FAS in this case, we created such page. So it was kind of internal report. And such a page would have the households, population, and employment. And we would have the observed data here in green, the previous forecast, here small area forecast in blue, and the current forecast here in red line is the median, and the shades show the intervals. And you would have the numbers here. So, and then we would give it to reviewers to look at it and give us their comments. So even though you have the uncertainty, the reviewers will still be fixated to the median line here. And they would come back and say, you know, out of these 200 zones, you can expect that you get all of them right? So they would come back and say, for this and this zone, this doesn't seem reasonable, and this is an example of such zone that they would complain, because as you see, households and population has stagnation over time. It doesn't grow. Within UrbanSim, it makes sense because we added lots of jobs, so households and population, probably wasn't much space there, but reviewers would say, no, this is not reasonable, we want to change this. Of course, it would be just up to me. I would say, well, actually, the model does not exclude growth, right? It's within the uncertainty, but the reviewers would want point prediction in this case. So we would use the uncertainty to give us a guidance how far we can manually change the predictions. And in this case, we would say, okay, so we change the prediction and go along the upper bound of this is 80% confidence intervals. And that actually turned out to be quite good strategy, because it would make the reviewers happy, and we were happy because we didn't have to kind of make up numbers, and would say, okay, the model actually does not exclude this possibility. So that would be the refinement stage. And of course, the published forecast. So we would now not have just one number, but we would put also the lower and upper bound. And Mark would create this nice table with bars so that you can compare the zones among one another. And to our knowledge, actually, that was the first time that MPO published such forecast, or published uncertainty information in their official forecast. Okay, right now I'm working on a scenario testing. So we do kind of stress testing where we compare results of different scenarios. So Without the uncertain information, what I have to deal with for each zone, I would have just two dots, right? And I wouldn't really know, is the change significant or not when I compare two scenarios. So if I add the uncertainty, it would tell me much more. It would tell me, you know, how, for example, this one you wouldn't say, is this significant or not? Here you would say, actually it is. Others, they are not. So this is very helpful. This is actually just a made-up example, and last week I worked on a real example, which was comparing two runs, one fully integrated with travel model and one without a travel modeling, meaning the accessibilities would be frozen at the base year. And I would plot these against one another for households and jobs, and you see the results, you say, well, they are very similar, but what can I say about it, right? So what is actually the noise, the random seed variation, or what not, what is significant? So I would add the intervals here, and I would say, okay, I see that some of them are actually, they are not crossing the diagonal line here, so they might be significant changes. So I selected only those that are not crossing the line, so I have fewer zones now to look at. And now I would be interested which of those had actually increased in both households and jobs, and which had just decreased in households and jobs. So these would be now in red. Red are the increase and green are the decrease. So I would just get a handful of zones that experienced that, which was then easy to put on a map, and I could see what is actually happening in these two scenarios. I would see that the decrease would be out on the outskirts of the area, and the red ones would be in more populated area. So that was very useful in that. It was just the kind of first analysis that I did with this, and was excited that actually I can use it for practical purposes, and that it helps to get out of the noise and just get the significant changes out of the comparison. Okay, as a summary, so uncertainty assessed via statistically grounded approach was included in official land use forecast, and as I said, as far as we know, it was the first time that an MPO would do that. We addressed issues such as number of runs and aggregation. I did not mention aggregation in this, but they are in the paper. It played an important role in modeling phase, output review, and refinements, and is essential for us now in comparing different scenarios. In future, we want to incorporate uncertainty in transportation outcomes, and we submitted a paper to GTLU, but if anybody's interested, I can send it to you. I have one more slide, some news from the PSRC modeling lab. So we work on land use and travel modeling, and this is our team led by Billy Charlton. This is alphabetically sorted. And on the side of the land use, so we basically identify two main uses of UrbanSim. We use it as the baseline forecast tool that we used in the official land use forecast, and we also use it as an allocation tool. And this is a case when we have when we want to force UrbanSim to place a specific number of agents, households, and jobs into sub-region like cities or zones. And that can be the case in the refinement that I talked about, but also what we do now, we try to let UrbanSim, or we have control totals for cities, these would be like land use targets, so like the aspiration of the local jurisdictions, and let UrbanSim to work underneath of those geographies like cities. So it would sort of allocate, it's not really forecasting in such a case. So we have a set of tools that does that, and it actually was pretty successful, or has been successful. And we now starting to do the stress of scenario testing, and we are very inspired by the policy levers that were done in ABAC. We use Opus UrbanSim so far. This is the reason for it is that we had a working forecast model and working set of allocation tools, so we didn't really feel the pressing needs for that. But our plan is to, on a parallel track, to investigate a new implementation and then compare these implementation, including a qualitative comparison. On the travel modeling side, so we will most likely use our 4-step travel model for Transportation 2040 update, and we use the EMI model. And parallel to that, in final stages, we are finishing activity-based travel model called Soundcast, and it's based on a DaySim travel model. And we have a new travel survey just finished, which is very exciting because we have lots of data coming for the travel modeling as well as for the land use modeling. And we will work on integration of UrbanSim and Soundcast. So if you now think this is really cool and you are sorry that you cannot be part of the team, I have a good news for you because we are hiring. And if you want to lead this work, it's a managerial position, then please apply. You would be my boss, and everybody else is on the list except Billy Charlton. And yeah, so I got the task not to, or I got told I shouldn't return with our list of candidates, so please talk to me. This is my email address. And yeah, if you have any questions to what I talk about uncertainty and other stuff, then yeah, please talk to me or you can ask now. Yeah, thank you very much.
I'm sure people have questions about the equations in particular.
So it seems that you have a lot of geographic variation in the uncertainty. You found a relatively few number of classes were highly sensitive, and most of them were actually not. So you figure out some of the geographic factors and what types of areas would show much more variability than others, and did you decompose it into it was data problems, or it was changing parameters over time, or did you get a sense of what was driving that?
So the variation
allocation tool was very successful. We have another story to tell how you use that.
Any time point that we want, for which we have UrbanSim outputs.
Okay, and you expect to
Oh, that's what you mean. So we would expect them actually to grow.
Right.
We have this propagation factor that we estimated, and also what it's doing. I think I forgot to mention that the whole analysis is done on square root scale. It was on the slide there. It's on transformation on square root scale. That means that if you convert it back to raw scale, then for larger, if you have, for example, in next year larger number of households than previous year, you convert it from square root scale to raw scale, it will be larger than in the previous year. But there's also the propagation factor as well.
In terms of selling this to your planners and your forecast consumers, is there any tolerance or threshold on coefficients of variation where you kind of gave them usage guidelines that these ones are safer than others?
You mean like safer, like what?
Higher confidence.
You mean like the bit of the intervals, or we could, so as I said, we published 80%. We could publish like 95, for example. It would have a higher probability that it happens, but on the other hand, they would be wider, and the danger is that they say, well, if you have such wide intervals, you actually are saying you don't know what's going to happen, right?
The Census Bureau publishes particular usage guidelines, with coefficient variation. And it's 25 to 30%. Start to become a problem. Relying.
So you can actually define that modular setup for the configurations in order to minimize that variance of configuration, which is permitted by the model. And with the expand twice, we expand that minimum variance.
I'm not sure if I understood that.
So I think this is the same thing that maybe you and I have talked about in the past, and you mentioned something along the line. there's all sorts of sources of uncertainty going into the model, and one of them is the model structure itself. What variables do you have in each model? And what would be a beautiful thing to do is to wrap these in all the search over alternative model specifications. So you find those specifications that actually reduce the variance, give you higher quality, tighter bounds, less uncertain long-term predictions.
So all of that can take back from that out.
Right, so what you can do actually, you could theoretically manually plug in the various different specification and run each run with the specification and then compute the weights. And then it will tell you which one is actually the best.
I wonder if you guys experimented with different levels of geographic aggregation. You use the FAs, the passes, and I don't know how many you have, maybe 300. But to get a sense of the overall sort of macro level accuracy of the model, does it get the regions, but the parts of the region roughly right, but not necessarily the passes? So if you go to a higher level of aggregation, you get less uncertainty and more accuracy in those boxes. But do you what I'm asking?
You're asking.
So going from a very fine level of geographic detail, such as FSC, you get much more variation. But if you aggregate like 5 of those and get sort of macro level, so you can say to policymakers, yeah, at this FSC, we have this kind of bound, but if you take 3 of those, roughly the model is right because it hit the dart in that general region, but not necessarily in a specific FAC. So playing around with the geographic level details,
yeah, and we have
and so that trade-off between accuracy and geography, ultimately.
So we have a section in the paper about aggregation, and there are 2 ways of aggregation with this. One is that you just calibrate on the aggregated level and do everything like, on the aggregated level, your variance and so on. The other way is to do it is aggregate on a lower aggregation level, but then once you have the theoretical distributions, you can simulate from those and aggregate that way. And there's a difference and in that, and I think the better way to do it is calibrate on the aggregated level, because it also includes uncertainty. It actually, there is also a correlation between the zones, and that catches also the correlation, whereas when you do it on a lower level, it doesn't. So, yeah, so we address that.
I'm just trying to think. Is there a way to use it in the backwards mode? In other words, so there's specific zone, and there's maximum level population of jumps. That's whatever level. Can you get the parameter? Can you get the model with the parameters that creates this outcome? Actually.
I don't think so. I don't think, no.
I think that's actually getting at a different problem, and it's a bit more similar to an exercise we did here in the Bay Area, where we had a preferred scenario that had been adopted as a policy. So it has specific zonal targets of employment and population by zone, and it was adopted by the policy board as a plan. And what we had to do is figure out how do you use the model to reverse engineer what would it take to get those results. And so Bayesian melding wouldn't help you with that. It might tell you what the probability of that outcome is for each zone. It might tell you whether you fall within those error bars. So what we had to do instead was test different combinations of zoning policy and subsidies to determine how you get arbitrarily close to that target using regulatory tools and set of structures. And this is actually part of the current work that we're doing with MPC to, I think the terminology that Mike Reilly adopted for this was a vision solver. Basically a reverse engineering of what policies would it take to get to a particular set of desired outcomes. It's a related question, but
the longer term, this might also combining the two things might tell us how much, because the vision solver calculates partially a bill in terms of subsidies to get to an outcome. Other policies can't do this, which gives us information about the maybe our bills lower.
Well, it might give us a certain distribution around the. I mean, we might be able to meld. Sorry, I had to go. Well, Hannah, thank you very much. You want to talk a little bit about what your processes are like, what you're currently working on, and then, if there's any, we can just have more broad discussion and questions. Maybe Dan?
Go ahead, Barry.
Either way, the only thing is, if you go up here and catch it on the screencasting through the microphone. Not that we like the formality so much, it's just that for those people that are listening in, it's very helpful.
Well, for those of you who, I met a few of you guys in San Diego this summer. My name is Dan Jarrett. I'm the Chief Economist with the Denver Regional Council of Governments. And I kind of just jotted down a list kind of last minute of things that I thought I would talk about today just with our experience. I guess I can say, and Paul, correct me if I'm wrong, but you might be the newest UrbanSim user. Yeah, so, and we're pretty lucky in that throughout our implementation process over the last couple of years, we've been able to basically implement right away UrbanSim 2. I guess that's how people have been talking about it. So we're in the Python, the lighter code. We're using the Performa developer model. So that's been pretty cool for us. The process was pretty smooth. For my 2 years, I guess. I think I missed maybe the first year or so of our attempts at bringing UrbanSim on as our land use model. And I can say that we just finished up our first round of forecasting with it in August, I guess. Yeah, I guess about in August. And we're in the process of updating our RTP, and that will, I think our travel model team has just kind of finished most of their runs just within the last few weeks using the new land use data set. And for the most part, we were really, really happy with the results of UrbanSim. We were a little hesitant, or I can say, I guess, as the leader of the team, I was very, very hesitant when we started this because we were, I think, frantically trying to finish the model at the same time as we only had a few months to then basically really get results out the door and results that we believed in. Early spring, I guess I can talk about our process. As we were kind of finishing the implementation of UrbanSim, we went out to our 56 member jurisdictions with a small area forecast, and we basically asked them at the zonal level, only about 2,800 zones in the Dr. Cog region, basically, what do you think? It was a very baseline forecast, and we were less interested in them kind of turning the dial of fidelity to say, well, not 100 jobs, but 105 jobs, but more just kind of a size and magnitude type of gut check. And also then any information they could give us in terms of, maybe it's a very mature area of Denver and that they expect no new developments. So, in the new implementation of UrbanSim, we were able to go in and maybe mark that zone, you could say, with like a no build. So we were going to make sure that nothing was going to happen in those zones. So probably the most difficult thing for us was how do you, and I guess this is probably the same for everybody, how do you match those local aspirations to UrbanSim and use it as a forecasting tool versus an application tool, I know a few of you have talked about, because our old land use model that had been in existence for the better part of the decade was very much our jurisdictions telling us exactly how many jobs they were going to have, and then just allocated those. So I will say, as far as results go, so we ended up calibrating to a 2015 control total with UrbanSim. We have a 2010 base year, and when we kind of looked at what our results were out in 2040, only was the allocation very similar to what we would have, well, when we looked back and compared our 2040 simulation of UrbanSim to our 2040 control totals, we were in the ballpark, which was pretty amazing. At the regional level, our totals were remarkably close, which we were really happy with. And then we could tell a story with our 9 counties in our region. Basically, UrbanSim did a really good job of being consistent with the story as well. So we knew that the city and county of Denver is our largest county, and that's obviously going to attract a lot of jobs and people. But then the other counties, that story kind of held consistently. So our process, I was very happy with it. The one thing I will say now is, now we have to look back and go and see, how we did take a lot of information from our locals. And obviously, we put a lot of that information in as, into kind of like a zone spreadsheet in UrbanSim, and now we kind of basically want to take a look at, what was the model saying before we put those adjustments in. And then, really, was it something that we were missing? Was it price? Was it zoning? And I can say for the Denver region zoning, we probably encounter a similar problem to everyone else in that a lot of the zoning is very loose. It's PUD, or it's, the developers can just go and basically present a project. So that's the hardest thing for us is our zoning data. And we're actually working with a consultant right now who's going and reading every one of our comp plans and zoning codes to try to tease out, basically, can we create, a floor area ratio data set that, is regionally consistent, and do we know what low density means in Jefferson County versus Denver, and then map that into a regional land use data set as well. So that's kind of where we're at with our process. I was just going to mention a few other things really quick, and then I guess I have questions. I think our biggest going forward is integrating UrbanSim into our activity-based travel model. We're still obviously refining our travel model quite a bit. This time around, we held our abilities and a lot of our travel variables constant across our simulation, just because we didn't have enough time to iterate back and forth. The travel model runs a little bit slower than UrbanSim. So we're trying to figure out better ways to make that happen, especially over the next couple of years. Obviously, that's what we want to see happen, and maybe just swapping back and forth at 5-year increments all the way out through our forecasting horizon. We're going to start a base year update probably beginning of next year, and then move our base year from 2010 up to as current as we can get, and we're hoping that then we can have a little bit more data for validation, because we were lucky enough to have a 2010 base year data set, starting right off the bat, but that doesn't give us a lot of actual data to really kind of test against. So we're looking forward to going after that, and we actually we're kind of in between, I guess. When Mike mentioned earlier that their jurisdictions here in the Bay Area are going to start using UrbanCanvas as a tool for database management and quality control, we're actually in the process of implementing something that we're calling a data portal, and our GIS. Our structure is a little different too in Denver, in that my team is a team of economists and modelers, and then our travel team is separate, and then anyone who works on GIS is separate in a department, and they're responsible for all of our data collection, all of our data, which is pretty unique. And they have gone out, created a data portal, and basically it's trying to streamline the process of how we get data in from our members, but also out to them, and hopefully encourage them to be a little bit more forthcoming in terms of sharing. So it'll be a lockdown site for all of our members, but then when they upload a data set, for example, we're forcing them to check some boxes and say, who can this be shared with? How public can it be? Because that's one of our challenges, and I think one of the challenges why we weren't maybe ready to jump on UrbanCanvas as a tool for that, just because we have we have an individual data sharing agreement with every single one of our member jurisdictions, so it just doesn't allow for that right now. But I would hope that that's something that we can move towards. I guess the other big thing that we are trying to work on, and that I'm really looking forward to working with Paul and his group on over the next 6 months, a year, is how do we integrate UrbanCanvas into our work beyond just a quality control tool, but to really take advantage of all of its new abilities. So. What else can I say? We're actually also about to start building a macro forecasting model. So far, we took our regional control totals this time around from the demographer's office. Had to do some proxying, but what we're looking forward actually bringing that in-house and actually working closely with the state demographer's office. We're going to always rely on their population forecasts, but they actually rely on us, or they would like to rely on us more for employment and anything more economic. So they forecast population at the county, but then for any of the economic variables outside of population, they aggregate up to what they call a region, and there's a handful of regions in the state. So they look for us, or they look to us to basically give them fidelity on, county by county employment. So we're going to start that process, and I know a few other MPOs are also kind of starting to think about econometric models and be happy to have discussions and join in those too, because I'm not quite sure what method we're going to go with. So I don't know if there's anything else I can mention, but that's kind of a quick update where we're at. So happy to take any questions.
All right. Thank you very much. And Dimitri, do you want to make any comments last time? That's a great comment.
I can just quickly. So. We've been affiliated, associated with UrbanSim for quite a while. We used the original retail model quite a while. Then when the UrbanSim went to open space, it was we wanted to use it, but it was kind of quite complex to us. We didn't quite understand what was going on. We just probably more of our lack of expertise in Python, so we decided to re-implement some of the, not everything, but the key real estate modeling in SAS. So it sort of does the same thing as UrbanSim thing. And now we're looking more and more. We're excited about the new developments, new implementation. The code is much simpler. It's sort of more transparent, and we're particularly excited about the UrbanCanvas and other suite of tools to go with it. So we, at some point, we want to join back with the mainstream UrbanSim framework. So, but our forecast. So currently we're using our own version of UrbanSim to produce a forecast, and the way we decided to do it, we essentially update our forecast every quarter, so it provides a continuity to it, and we show our forecast, at least the land use part, not jobs and people at the parcel level, and we developed a tool to communicate its results. We're on the web, and we're also very much interested in. So we have the tool whereby people can submit feedback to us, or whether for parcels, casas, census tract, or whatever. And interestingly, our experience is that the more open you become, the less questions you get from people. That's just at least in our experience. So I would fully endorse going transparent and only work, and certainly suggest that this is a better way to.
Thank you. Right. And Andy Lee, I just saw coming to the back.
I'm still busy from the bar, so.
Okay. You want to make any comments from WFRC?
Here we go.
Okay. We can do that over lunch.
Yeah, basically we have been working with the data, and now in the last year, most of our focus is on working with the local experts that belong like financial companies, real estate agencies, and also those real estate developers. We try to get some inside ideas that they can provide that we implemented in our model. Now it's helping us to come to a side, and in the coming year we will evaluate more the information.
Right. So thanks everybody. I think it's time for lunch break.